So in this lecture, we're going to develop a new method, right? We already have our factoring method for solving equations. Now we're going to look at a new method. It's called the square root method, and it relies on this square root property. What this says is, if I have something squared equals something else, then this is the same as A equals plus or minus the square root of B. And the way I always think about this in my head, that I remember this, right? Think of it as taking the square root of both sides, right? The square root of A squared is A, and the right-hand side is plus or minus the square root of B. Now, we need both of them here, right? Both the plus and the minus, because when you're solving an equation, you want to get all the answers, right? And plus the square root of B squared is B, and minus the square root of B squared is also B. So we need to include both of those. Really make a big note of that to yourself. That's one of the most common errors I see in students who are using this, is they forget that plus or minus, and they end up losing literally half the answers. All right, so let's see how this works. I've got this situation here. You notice I have something squared on the left side and a number on the right side. So our square root property says this is the same as x minus 3 equals plus or minus the square root of 10. Now we're home free. Add 3 to both sides. X equals 3 plus or minus the square root of 10. And it's that simple, right? There's our answer, and we're done. All right, so let's look at another one here. This one, there is one other little twist to this. So let's use our method again here. You see we do have the right setup. We've got something squared equals a number. So this means x plus 2 equals plus or minus the square root of 12. Remember, with square roots, you always have to stop, say, can I simplify this? Because I think we can here. This is plus or minus 12 is 4 times 3. And I know what the square root of 4 is. So x plus 2 is plus or minus 2 times the square root of 3. Now subtract 2 from both sides. Negative 2 plus or minus 2 square roots of 3. And there's our answer, right? It really is that straightforward. So let me give you one, right? Try solving this yourself. Then, pause the presentation, see what you can do. Start it up again, and we'll go over it together. All right, so we're going to use our new method. 2x plus 3 equals plus or minus the square root of 24. And I can simplify here, right? 24 is 4 times 6. So this is 2x plus 3 equals plus or minus 2 times the square root of 6. Subtract 3 from both sides. 2x equals negative 3 plus or minus 2 square root of 6. And one more step, divide everything by 2. X equals negative 3 plus or minus 2 square roots of 6 over 2. Now look here, so I got to stop here and talk about this for a second. Be careful. Do not try to reduce the 2 on the bottom with the 2 in front of the square root. You cannot do that. Remember, the only things that you can cancel are factors. If this was something like 2 times 3 plus or minus the square root of 6 over 2, this 2 on the top is a factor. That I could cancel with the denominator. But this 2 in my answer, that's just part of that second term. So there's nothing I can do with it. You got to leave it alone. All right, so this is our square root property, and it really is an important tool. So I want you to think about what we can do now. We can solve equations that we would never have been able to solve before. Right? If you take this one we were looking at here, if you multiply out that left-hand side, it becomes 4x squared plus 12x plus 9 equals 24. Set that equal to 0. Subtract 24 from both sides. 4x squared plus 12x, what's this, minus 15 equals 0. That doesn't factor. Absolutely not. So previous to this, we'd have been dead in the water. We would have had to say we can't solve it. Right? So the square root method is a great step forward because it lets us solve equations that we would never have been able to solve before. The problem is it has this requirement that the equation has to be in this very strange form. It's very rare that you're going to see an equation that looks like something squared equals a number. So our challenge that we're going to address in the next couple of lectures is there a way that I can take a generic quadratic equation, like this guy here for that matter, right? This thing, and manipulate it and rewrite it so that it has this specific shape that I needed to have in order to use my square root method. Right? So that's going to be our topic for the next couple of lectures.